Hello everyone. Today I am going to deliver a lecture on structural analysis by direct stiffness method for only for 3D Truss. Before I am going to deliver elaborately explain the 3D Truss, I want to say why we need to why we are going to solve the using the direct stiffness method. Okay, so if we go if we go to this table, we can see there are lots of method in existing. So we have been seen in virtual work method we can use only for determinate and indeterminate structure, but use there is no use for forces, but we can use for deflection also. So in the same way we can use unit method, we can use the force, but when you use the force method, we cannot solve the determinate structure, but we can use the indeterminate structure. In the same way, the moment distribution method we cannot use the determinate structure and indeterminate structure. So we are saying this, we are now today we are solving the stiffness matrix method, so we can solve the determinate structure and indeterminate structure, and we can use for forces also, and we can use for deflection also. Okay, so I hope you can understand why we are going to solve why we are using the direct stiffness method. Okay, now we can apply this method, I mean direct stiffness method. We can solve various structures, so such as we can solve the 2D truss or 2D beam or 2D frame. In this way we can solve that 3D truss, 3D frame, 3D grid, and so many things. And we can also solve by direct stiffness method. We can use the non-linear problems such as geometric non-linearity beam and frame, and plastic analysis beam and frame, and direct stiffness method for structural dynamic analysis. So uh, as we are going to explain the direct stiffness method, we're just taking only one part, which is uh, 3D truss. Okay, so that's why our title is structural analysis by direct stiffness method only for 3D truss. Okay, so let's see. So at first I want to see some theory which is called the member stiffness matrix in global axis system, and then we will see the assembly of stiffness matrix, load vector of three-dimensional trusses. Okay, and then last one we will see the math example. Okay, let's start from the theory which member stiffness matrix in global systems. If we go to the here, we can see the three-dimensional trusses. The three-dimensional truss having three unknown displacement at each joint, such as deflection and u-axis, u along x-axis, and deflection b along y-axis, and deflection w, we can see z-axis, and therefore the size of the member stiffness is, we can see 6 into is, which is 36. And sx, we know we know the stiffness, which is ei divided by l, and the stiffness matrix in global system we can see sx, and it will be like this. Okay, so the member stiffness matrix in global axis system we can see here, uh, c square cx, cx c square, like this, and cx. So if we divide here, so we can divide like this way. Okay, like this way. At first we can take the only x direction, which is c square c x cx. So all are the cx in first row, and we can use cx into cx, that's why cx square, and then cx into cy, that's why cx cy, and cx into cz. That means first row is x, all will be x, and second row will be all will be y, and third will be all will be z. In this way the row second row is cx, and it will be multiplied, the column will be cx cy and cz. such as cx, cx, cx. Now we are multiplying with cx, because this is the uh, x column and this is the cy column. Cy and cy, it will be cy square, and cy and this is the cz column. So cx into cz. Okay. So in this way we can take the row. This is the third row, we can say cz row. So cz into cx and cz into cy, cz into cz into c square. So we can see here the all the diagonal are x square. So c square, cy square and cz square. So uh, uh, we can easily remember that c square, cx, cx, cy, cx, cz, cy, cz. Then first row will be cx priority, and second row will be cy, cy, cx, cy square, cy, cz, and third row will be cz. Okay. So where cz is alpha, cos alpha, and cy equal to cos beta, and cz equal to cos gamma. So alpha, beta, gamma are the angle of member mixed with the coordinate axis x, y, z respectively. After assemble the stiffness matrix, the load vector, and apply load boundary condition uh, condition the unknown displacement, and calculated by the standard method of solving a simultaneous equation. Once the displacement are unknown, the member force are calculated by the following equation, which is P, which is the member forces, and Sx is the stiffness, and B is the displacement of point B and minus displacement point A, and Cx, as we know, calculating by the angle, and B minus B, and C, C and A, and in this way. So if we know how we calculate, how to generate this formula, the you should be, must be memorize this formula, must be memorize this formula. I have shown how to memorize this formula. So if we want to see how it is taken from the lecture is taken from Buyet. Okay. uh, and this slide is taken from Professor Dr. Iftikhar Anam Sahab, University of Asia Pacific, Dhaka, Bangladesh. And this slide is taken from Bangladesh University, uh, University of Engineering and Technology. Maybe it's Professor Dr. Amanush sir. Okay. So we can see here the pin connected plane trusses, stiffness of the truss element. We can see here the two joint, which is I and another is J. So the first node I, this is the first node, and second node is J, this is the second node. The element length vector from I to J is Ij, and angle Y is measured the anti-clockwise, is always anti-clockwise at first node I. This is the first node I. So we can see cos Y equal to as we know the Pythagoras formula, xj minus xi divided by length, and equal, it is called the cx, as we have been known here, the cx. And in this way, sin y, we can use the yi minus yj minus yi divided by L, which is the Pythagoras formula, and we have been found the cy. Okay. So we can see the element distance vector is here. All the elements is given, such as the node 1, we can see the displacement u1, and vertical is u2, and the node 2, we can see u3, and vertical u4. And the same way we can say I, so we can say 2i, the x-axis is 2i, and vertical is 2i, only 2i minus 1, and vertical is 2i. And another j, we can see it 2i minus 1, and vertical is 2j. So we can see here the 2i is here, and 2i minus 1, sorry, 2i minus 1, and this is the 2i, this is the 2i, and 2j minus 1, this is the 2j minus 1, and j, and this is the, so we can say this is the horizontal, and this is the vertical, and this is the horizontal, and this is the vertical. the, just because of the element node. So you can say this is the first node and this is the second node, so this is the distance. The first column element, we can say stiffness matrix, as we have been seen here in this way. So we can say c square cx, we can say c square, this is the c square, and cx cy, this is the cx cy, and this is the negative, this is the first node I, and this is the second node, we can see the minus cx square, this is the minus cx square, and it will be cx, this is the cx cy in the second node, and ei will be constant. So in this way we can from this equation the Truss element matrix. So we can see 2i 1 equal to c square, as we have been seen in previously, and cx cy, this is the for two dimensional, but we have been seen that three dimensional it will be formed this like way. Okay, I hope that you can understand this is the members matrix and global assembly, and assembly of the stiffness matrix in global vector in three-dimensional trusses. Okay, now we can see the math example of the 3D trusses. So let's see. Here is the an example. We can see here the global assembly stiffness matrix, and write the at first I have been uh, what else? I've been reading the question. The question is assemble the global stiffness matrix and write the global load vector of the three-dimensional, which is 3D trusses shown in below. Also, write the boundary condition, which is okay. So ei divided l, which is called the stiffness is constant, which is given 500 kPa. So let's see. This is the our diagram. So you can see this is the pin support, and this is also pin support, and this is also pin support. This is the diagram, and I have also writing here from my convenient purposes. So I have been seen this, the distance is given 10 feet and 10 feet. So these are the 10 feet and these are the 10 feet, and height is also 10 feet. So that's why I have been all the coordinate I have been writing here, such as x y z, and that in the same way x y z. Okay, so so we can say this is the a, and this is the point of b, this is the point of c, and this is the point of d, and all the paint joint is given here. Just there is a load is applied point d. Okay, so we just saying here u1, that means displacement in as x direction, and u2 is displacement in vertical direction, and u3 displacement in z direction. If we see this diagram, we can see this is the x direction, this is the y direction, and this is the z, or we can say this is the z. Okay, so in this way we are marking 1 2 3 1 2 3. And now if we go to the second node, which is the point b, so you can say this is the x direction, which is called u4 displacement 4, and u5 is displacement 5 is vertically, and uz is displacement in z direction. In the same way, we can see that displacement 7, which is the point c, which is the displacement in x direction, and displacement is vertical u8, and displacement is z direction u9. And the last one we can see here, the displacement 10, u10 is x axis, and u11 is vertical, and u12 is z direction. Okay, let's use this equation. This equation, I want to say this equation only valid for support are when support are ruler, we cannot use this equation, as we have been seen all the support are pin support. That's why we can use this formula. Okay, so I just write in here the member id, which is db. This is the d. I just change it. If I change the color, this is the d, this is the b. So this was the db. In the same way, cd as dc, this is the dc member is here, and da, we can see here the da is the direction we have been seen. This is the d, this is the a. Okay, let's see the first member, which is db. This member, we can see this member. Okay, the lx, the distance is given is here lx, that means x distance, which is 10, I have been seen here. So 10x, and ly we have been seen there is the ly is 0, as we have been taking the coordinate 0 0 from calculating point d, that's why the y is 0. Okay, so ly is 0, lz we have been seen also 0. Now if we calculate L, that means square root of Lx square Ly L square plus Lz square. After the calculating, we have been found 10. Okay, now if we calculate the Cx, what will be the value of Cx? Cx is nothing but it will be Lx divided by L. Lx what? Lx we have been found 10, and L is also 10. 10 divided by 10 is 1. So Cy, what will be value of Cy? Cy is nothing but Ly divided by L. So Ly is 0, and divided by L will be from 10. 10 divided by 0 is 10, is 0. In the same way, we can calculate Cz, which is Lz divided by L. The Lz value is 0, and L we have been found 10. So 0 divided by 10 is 0. Cx square. Cx square, that means we have been found 1. 1 into 1, so this is the 1. Cy square, we have been 0 into 0 is cx square. Cz square, we have been found 0 into 0 cx. So cx cy, we have been found this is the c, and cx this is the cy. 1 into 0 equal to 0. Cy cz, this is the cy, and this is the cz. 0 into 0 into also 0. And last one we can see cz. Cz, that means cz cx, this is the cz is 0, and it will be multiplied 10, it will be also 0. So this is the member of db, this is the member of db scenario. Now if you see the another member, uh, let's say the dc. So let's see the dc member. This is the dc member, this is the member. The x direction is 0, y is 0. So lx is 0, ly 0, but lz is minus 10. So lz is minus 10. After calculating here, some square root of square root of lx square plus ly square plus lz square is, it is found for 10. And cx, it will be multiplied in same as it is lx. This is the lx divided by l. 0 minus 10 equal to 0, and also 0 minus 10 equal to 0, and 10 minus 10 equal to minus 1. And after in the successively we have been calculating here. If we calculate dA, so let's go to the dA. This is the dA. The dA x is minus 10, so we have been taking the minus 10, and y is minus 10 also. This is the y is minus 10, and z is 0, as we have been seeing, this is the 0. Okay, so now calculating L. How we calculate the L? Square root over L square, L y square, L z square, and found 14.4. And cx, how we calculate cx? Cx is nothing but lx divided by L. Lx is minus 10 divided by 14.4, and found minus 0.7007. And cy, in the same way we can calculate ly divided by L, and found minus 707. And lx cz will found as lz divided by L, and it is 0, as the lz is 0. And cx square, how we calculate? Cx square is nothing but is here minus 707 into minus 707, minus will be plus in 0.50. Cx square, how we will calculate the cx square? Cx square minus cx into cx into cx will be cx square, as the value is minus 707, and minus 707 will be 0.50. And cy, as we know, this is the 0, that's why 0. And cx cy, how we calculate? This is the cx, and this is the cy. Minus 70 and minus 70, it will be positive 0.25. And cy cz is 0, as this is the 0, and this, and after calculating, and we can use the summation. After all the summation, 1 plus 0 plus 0.5, that will be 1.5. 0 plus 0 plus 1.5, it is 1.5, and it will be 1, and 0.25. And in this way we will calculating here. Now we are going we are assemble this this the formula, as I have been shown here. There must be memorized. There is no other option to memorize. Cx square, cx square, cx y square, cz. So we just putting here c square, cs, all the value is putting here. After putting here, we have been shown our our diagram, we have been shown only the force is applied, only force is applied in node D. There is a node D. That's why we are taking the node D. Other all the direction is not free, not free. All the restraint. This point, F point, B point, D point are restrained. That's why we take not will not take this point. We just take the point of D. Why? Because these are free. This is the load is applied this here. Others the F point, D point, and P point are restrained. It will be cannot move in x direction in y direction. Okay, that's why we have been just taken here only this portion, which is 10 u displacement in 10, displacement 11, and displacement 12. If we go to this picture, we have been seen here displacement 10, displacement 11, and displacement 12. Why we chose this element only? Because this is the free. Otherwise all the another point are fixed. That's why we will not take another point. That's why we take another point. We have been just cancel out, just taken the 10, 11, 12, and we have been taken 1, 2, 3, and it is also 10, 11, 12. This is the 10, 11, 12, and this is the 10, 11, 12, and 1, 2, 3. This is the 1, 2, 3, as we've been taken here. This 1, 2, 3, this point. So we have been calculating DA. 1, 2, 3. 1, 2, 3 is restrained as the pin support. So that's why we are cancel out. This is the 1, 2, 3, and 1, 1, 2, 3. All cancel out. We just remaining this formula. Okay, after remaining formula we've been seen 10. As we know, K equal to S X E into equal to F. K delta, we know K delta equal to P. So this is the value of P. I'm just erasing all the nodes. We know that K delta equal to P. Okay, these are the K, these are the delta. If I change the color, these are the K, which is stiffness, and this is the delta, and this is the P. This is the U1, U10, U11, U12, as we've been known here. U10, U11, U12 is we have been seen here. This is the stiffness, this is the displacement, and this is the P. P is given here. We have been seen in the diagram. This is the 10, 12, this is the 12, this is the 10, and another is 0. So 10 is x direction, and 20 is vertical direction, and z direction is 0. That's why 10 minus 20 and 0. After finding this value, we can write in this way, in short form. How we get the 500 is 00 is given value of K EI divided by L is given in question. So we just put in 0, and we are c square c z square, as we have been founding here. We just taking here, I just saying c x square. So c x square, we have been seeing c x square is 1.5. So putting 1.5 here, this is the c x square value. We have been putting this value. So now if we putting the c x c y, and now we go to the previous slide. This is the c x c y, which is 0.25. Here is the 0.25. This is the c x c y. Now we are also taking the c x c z. So we have been saying c x c z is 0. So we just putting this value is 0. And in this way, how we'll get this value? This value is cy cz. So we know cy cz is also 0. So we just putting the value is 0.25. Sorry, it will be cy cx. CYCX, that means this value CYCX, uh, CYCX, and founding 0.25, this is the 0.25. Okay, and another found is cy square. So I will get the cy square. This is the cy square. We have been founding this value 0.50. After putting this value 0.50 is given here, and then we have been found cx cz z will be 0, cx cz is 0, this is the 0, and funding cx cz is 0, sorry, cz is 0. Now we can see last one, which is this. I will get 0. This is the cx cz cx cz cx. This is the value of cz cx, and putting this value is 0. And now how will get the CZCY? CZCY is also 0, so we are putting this value is here, CZC0. And last one we have been found 1. How will get? This is the CZ square. CZ square. This is the CZ square. Summation of all CZ square is 1, and founding this value is 1. Okay. And U10. Why U10? Because we just taking, I have already said, this is the A point is pin, that's why the we will not consider B point is pin, that's why we will not consider C point is pin, that's why we will not consider. But we have been seen here there is no support, we just the all the load is applies x direction, that's why we are taking the x direction is UZ, sorry, U10, U11, U12. We just renaming his, this is the displacement, and this is the K, which is stiffness, and this is the P. As we know, these are the main equation. Okay, this displacement U10. What is the U10? U10 is nothing but this value is U10, as we have been seen here. These are the U10. U10 is x direction, and U11 is here. U11 is a vertical direction, and U12, sorry, U12 will be z direction, U12. And what will be value, as we have been seen, is 10. The U10 is 10, which is applied in s direction from left to right. And another one we have been seen, the U20, which is applied from gravity from up to down. This is the 20 up to down, and uz is 0. Okay, after finding this value, we just how we'll calculate this value. So let's see how we'll get the next slide, next value. So 5 into 1.5, 5 into 1.5 into multiply with u displacement 10 plus, and second one, if we now we'll take 5 into 0.25 into u11. So 500 into 0.25 into 11 plus 0 plus 0, because this is the 0, that's why 0 equal to 1, 10 equal to 10. So at first, how you assemble this 500 into 1.5, it will be multiplied 10. First row, first row, and then we have been shown the second 500.25. This is the second row, it will be second column, it will be second row, and the last one we can see here 0, it will be multiplied u10, as this is the 0, that's why we will not taking here, and it will be equal to 10. Now we're going to the second one. This is the second one. I'll calculate 500, this is the 500, and u10, this is the u10 to 0.25, this is the 0.25, and 500, 0.50, and u11, and last one 500, it will be multiplied with 0, that's why we are not taking this, all are the 0, equal to 20, this is the 20. and and last one we have been seen 500 into 0, it will be 0. 500 into 0, it will be 0. So 500 into 1 into u12 equal to this value and finding three equation. So after finding these three equation, so we have been solving from this calculator. As calculator we have been if we taking all this value here, then we have been solved this equation and finding u10 equal to 0.02 feet and u11 equal to 0.095 and u12 equal to 0 feet. Okay, these are our first answer, as we have been found the global matrix vectors. And now we can find the member forces such as FDA, the force of DA. Where is the DA? This is the D, this is the A. So uh, if we want to now we are finding the value of member of DA. That means this member. Okay, so we have been seeing we are taking the CX value, CY value and CZ value. So this is the CX, open the door. This is the value of CX, CY and CZ value. And after taking this value, this is the please open the door. So now we are seeing the member forces. How we will calculate the member forces? The member force is calculated equal to Sx, xx equal to greater than Cx equal to the difference of horizontal here. So we can horizontal of u. Okay, as xx equal to xx is given is 500 in the question, as we have been shown here 500, and cx value is found 0.00, and horizontal difference of u1 minus u10. Why u1 and u10? As we are taking the dA, this is the value of d into a. So as at first we are taking u1 and u10. Where is the u1? This is the u1 and u10. This is the horizontal distance between. Okay, and then if we calculate the difference cy and horizontal difference u2, u11. Why u2, why 11? Because this is the vertical u2 and this is the u11 vertical. In the same way, we are taking another one. If we here cz equal to u z axis, which is 0, cz is value is 0, and u3 u11. So if you show here u3 is z axis and u12 is also z axis. So in this way we can calculating here the member forces. After calculating all this value, then we have been founding the member forces to 23.33, which is compression is minus as the result is shown the compression. In the same way, summation of dB, that means member of dB, which is the D and B. These are the member dB. Okay, so dB cx cy cz is taken and sx is 512 and cx equal to u4 u12 and putting all this value and found compression, and cd also found compression is here. Now we can see here calculate the joint deflection, support, reaction and member forces of the space truss angle in the class. If the support A is settled, if the settle down 0.1 feet vertically downward, and uy by L is given 5 feet. So this is the point of A, and this is the B, and this is the C, and this is the elevation, and this is the plan. If we show the plan as the given, the coordinate minus 20 20 0, and there is 20 40 and height is 20. So we're taking the 40 0 0 0 20 minus 20 for 20 0 20 0 0 0 and this is the 0 0. Okay, let's start. In the same way we have been seen, this is the pin supported, that's why we can use this equation. Otherwise, if the ruler support, then we cannot use this one. So member id is AB, that means where this is the AB, A and B, this member, the Lx is found, Lx, Ly, Lz, and L, how will get the L is the square root of L square, Lx square, Ly square, Lz square, and Cx, how will get the Cx, Lx divided by L, and L, Cy, how will get the Cy, Ly divided by L, and Cx is also Cx. Now we'll calculate the Cx square, Cx square, Cy square, Cz square, Cx, Cy, Cz, Cx, and after finding all this value, and we can the sum of the all this value is here. Okay, so we have been seen here, 1 2 3 is cancel out with just 4 5 6. Why? These are the important. Why we are taking only 4 5 6? Because we have been seen, we've been seen here, we just taking, these are the 1 2 3, this point is 1, these are the pin support, that's why we will not take in here. These are the uh, uh, 4 5 6, these are the no support is here, that's why we are taking here. On the other hand, we have been seen here 7 8 9, these are the also support, that's why we will not take in here. These are the free member, which is 4 5 6, that's why we are taking the here 4 5 6, we all the 4 5 6 is given here, and all other is cancel out. So we just putting this value 4 5 6 in this portion, as the memorizing, these are the memorizing formula, and finding this value. So we have been 4 5 6 is value, all the value is putting here for 1, which is x square is c square, we have been found here, the c x square is 1, and another is this is the one, and how will calculate 0 0 cx cy, if we go to the cx cy, it will found with the 0. In the same way, cx cz minus 5, how will get minus 5, this is the cx is the minus 5. So in this way, we just putting all these values here and finding this value, and find, how will calculate this equation. The equation will be 500 will be multiplied in 1, this is the 1, and the displacement is e1, the first displacement, and the in this way sequentially we are taking the second one, as the second one we've been shown the 0, that's why we will multiply 0, and we are not writing here in detail. And third one we have been found 500 is here, 500 is here, and it will be multiplied with last one we've been founding in the 0.005. Okay, so let's see here, we can see here the 500 is here, last one we can see 500 minus 5 is given minus 50 in 0, and it will be multiplied minus 500 in 1. Okay, so in this sequentially we can we are also we can found this 3 equation. After solving 3 equation with this calculator, then we've been found this 3 value. I will get the member forces. In this way we can also, we at first we have been taking this value from here, this value are taken this chart, and we have been use sx into cx into u1 minus u4, u2 minus u5, u3 minus u6, and in found the member of AB is a positive, that's why the tension. In the SE we will found in this the tension, the all the member, all the values taken from this chart and finding this value, and this is the compression. Okay, so the member force, last one we have been found FAD is the all the number is taken here, and putting all this value here and finding this value. So let's see another example. Calculate the member force and support load is, all the support is given here. If the joint A, this the joint A is move 0 1 rightward and 0.5 is downward due to applied load no displacement in z direction. So let's see, this is the elevation, this is the plan. We've been seeing this is the A point, B point, C point, A. This is the A, C and B, and this is the D, this is the D point. So we've been shown all the, these are the pin supported, and these are the um, this and the joint. So we can just use the use point of D, which is U10, U11, and U12. So that's why this is the U1, U10, 11 and 12. So we just use this formula, U10, 10 to 11 and 12. Okay. So so in this way you can member, we are giving the member ID and Lx we have been calculating here in as we've shown in previously, and L, which is summation of Lx square, Ly square, Lz square, and Cx Lx, we are calculating the Cx. How we calculate Cx? Cx equal to Lx divided by L, Cy equal to Ly divided by L, Cz equal to Lz divided by L. In this way, Cx square, Cy square, Cz square, and Cx, Cy, Cz and Cx we have been calculating in this way. Okay, so now we can see, after putting after getting all this value thus we are summing all these values here. So we just taking the, this is the U10, this is the U11, and this is the U12. Why? Just because we have been seen this are the this is the free, and this is the load is given here. On the other hand, we have been seeing the joint A, B, C are the pin supported, pin supported. That's why this will be restrained. That's why we cannot take this A, B, C point. And on the other hand, we have been seeing the point D is not restrained. That's why we have been taking this point D, which is 10, U10, U11 in U12. This is the 10, 11, and another is 11 is we have been seeing plan from the plan. So this is the 10, 12 and 11. So you can see so U10, 12 and 11. So how will get 0.30? 0.30 is nothing but point Cx square. So we've been, if we go to the Cx square, these are the Cx square, here the Cx square, 0.38, sorry, 0.38 is square. So how will get the point to 2.45, 2.46, nothing but this is the Cy square, this is the Cy square equal to 2.46. In this way, how will calculate 0.16? 0.16 nothing but Cx square, Cz square, sorry, Cz square. We have been saying Cz square 0.16. So so all this value putting here, and finding this like this. So after finding this value, we are just assembly the equation is here, equation 1 to 3. After finding equation 1 to 3, we just using this calculator for calculation purposes and finding this answer, which is U10, U11 and U12, which is U10 is 0 feet and U11 equal to 0.00083 feet and U12 equal to 0.00359 feet. I will calculate the member force. If we calculate the member force of TA, so at first we need this data. So we are taking this data, and this is the formula Cx equal to U minus U10, 0 minus 04, and this we are putting this value and finding here. I will calculate the member forces as it is been shown in previous. Member force of D, we are taking firstly this value and Cx and putting these values here, and in this way CD. We can see another, ignore the zero member force of the space A, B, C, D, E, F, G, H, I as shown is given figure, and apply the boundary condition to determine the stiffness matrix and force vector, and load vector is given here, and nodal condition is given here. So as we at first we have been identify the zero force member, as we know the zero force member is condition. So at first you have to apply the zero force member condition, and after applying all the zero force member, I have been shown here, this is the zero force, and this is the zero, this is the zero, this is the zero. So all maximum is 0. Okay. So zero force member will be cancelled out. Now we will calculate the ED. So we will calculate, this is the E, and this is the A, B, C, D, D. This member is ED. We have been shown here EF. This is the E, and F, I, G, H. This is the F. This is the F, and another one is EG. EG, EG. This is the member of EG. So these three member will be calculated, and other all the member will be 0. Because why 0? Because they are the zero force member. That's why there's all the member will be 0. Okay. So in this way we can calculate LX, LY, LZ, and will be L, and CX, CY, CZ, CX square, CY square, CZ square, CX, CY, CY, CZ, and CZY. And after calculating, and we will sum the all value. These are the sum will be taken is here. And funding, we know this, we are applying this equation, C square, CX square. After we will use this equation here. Then after applying, we will finding this equation. So we just taking this pointer at the free, which is point 12, 13, and 14. So 12, 13, 14 will be 0. So 12, 13, 12, 13, 14 will be 0. So how will find 0.90? 0.90 is CX square. This is the CX square is 0.90. How will find 0.44? 0.44 is CZCY. CZCY. This is the CYCZ. That means CZCY is here 0.44, and finding all these values here. And this is the K. This is the displacement, and equal to P. This is the load is given here 58, as we have been shown here. The 58 is applied, and finding here, and assemble this equation. How will assemble? 1200 will multiply 0.90, and it will be first displacement, and second displacement, what will be 500 into 0, it will be 0. That's why 0. 1200, it will be multiplied 0.23 to 0.30, it will be it will be displacement, last displacement, which is U14, and equal to 58 is the first load, and it will be for the same as for second load, and third load will be calculating here. After finding this equation, and we just using this calculator and finding this below. I just skipping to calculating here. If we show the this value here, then it will be take the lots of time. You just if you need, you just scroll down in Google how to solve this three equation in using this calculator, and you will find the solution. Okay. So now we'll calculate the member forces. How will calculate the member forces? At first we will calculate the ED, member of ED. If we go to the member of, this is the E, this is the D, this is the ED member. So if you now we're taking the all the information is here, and putting the value is value is coming is compression. Another is EF is also compression 61.66, and EG is also count from 0.009 is also compression. Another one, we can see the ignore the zero member force of the space is name MD and as shown in the figure given is known, and apply the boundary condition to formulate the stiffness matrix, and load vector is given here, and nodal coordinate is also given here. So at first we have been identify the zero force member. These are the 0, these are the 0, these are the 0, these are the 0, 0, 0, 0, all the 0. Okay. So we've been shown the ZI. That means these are the ZI member is not 0, and ZM, this is the M, this member will be not 0, and ZD, this member will be not 0. Only 3 member will be calculated, and all the others member will be zero force member. Okay, that's why we've been taking ZI, ZM and ZD as we've been shown here, and taking the LX, LY, LZ and calculating L. How will calculate? Root over square root of L square plus LY square LZ square. And taking the Cx, I will calculate Cx equal to Lx divided by L, Cy equal to Ly divided by L, Cz will be Lz divided by L, and finding the Cx square, Cy square, Cz square, Cx Cy Cz and Cz Cx, and putting all this below, we are just summing here, multiply, we are summing all this here and finding this row. Okay, now we are calculating, we are just putting this equation as we will known. This equation must be memorized and finding this u1 to 3. Why u1 to 3? Because these are the free, and another one we can see all this node, this joint, this joint and this joint, all three joint is being supported. That's why it will be restrained. That's why we cannot take this point. Only we can take that this point of z, which is called 1 to 3. We have been shown here u1, u2, u3. Okay, so we can see u1, this is the u2 and this is the u3. Okay, we've been taking all this value. How we will get the 0.40 is nothing but cz cy, means cy cz, which is 0.40, and putting all this value is here. After finding this value, this is the k, we can see this is the displacement equal to will be p. I will find 58, 50 is given is here. This is the applied load. Okay, and after finding here, we can just assembly this equation 1 2 3, and after assembly this equation, we just putting calculating here and finding this u1, u2, u3. Okay, so we can see another is the ignored zero force member, and the space is given in zeta is given in shown in figure below, and boundary condition and formulate the stiffness matrix vector and given is below, and nodal analysis is how we can see the nodal coordinate. All the nodal coordinate is given here. So after putting here, which we have been seen here, mu, that means mu, this ma, that means this mi, this is the mi, and mz, this is the mz. So all other than 3 member, all member will be 0. Okay, so in this way mu, ma, mi, mz, so we've been seeing here all the other member will be 0 forces member. Okay, so we'll calculating this all the equation, putting here as it is previous, and finding this value. So we're taking this equation as we know. This is the equation. We have been seeing these are the u1, u2, u4 are the 1 2 3. This is the 1 2 3 are the free, and other will be 0. That's why we will be taking this value. After putting this value, we just assembly these 3 equation and solving this equation using this calculator and finding this value. And member force, we've been seeing mu member force 13.6, and mi found 13 minus 13.06 is compression, and mz will be 27.7 and compression, and finding this value here. And now we can see here another is ignore zero member force is applied is here. The boundary condition for formulate the matrix of the space ABC is given here. Okay, sorry, just a little bit. Okay, we've been seeing here another another zero force member applied to the boundary condition. Formula the stiffness matrix in truss is given here. The Sx is constant 5 kilonewton millimeter, and nodal coordinate also given here. After forwarding, we have been seeing fp. These are the f, these are the b, this member, and ft. This member will not be 0, and other will be 0 as the 0 forces member. And finding T is Lx, Ly, Lz, and L will be square root of L square, Ly square, Lz square, and finding this value. And Cx, how will calculate Cx? Cx is nothing but it will be Lx divided by L, and Cy will be similarly Ly divided by L, and Cz will be Lz divided by L. And Cx square, Cy square, Cz square I will be calculating from in the same as it is, and Cx Cy, Cy Cz, and Cz Cz Cx. Okay, now we'll assemble this equation. How we'll get, these are the equation we have been seen here again and again. It will be memorizing. Okay, so we are finding here this equation, and all other the node which is called b d will be will not be d, will just take in the node of fd which is called u1 u2 u3. These are the u1 u2 u3 displacement, and taken here. How will calculate 0.40? 0.40 is nothing but c z square. If you go to the c z square, this is the c z square in 0.48, and finding this here, and after putting this by, and we will assemble this equation 1 to 3. After calculating using calculator, then we will found u1 u2 u3 displacement. In the same way, we can calculate in the member force. We have been taken here the member force fb. If we use this formula, and fb and fd, we can use this formula. Thank you everyone. If you have any question, then let me know. These are the in that before I'm going to leave, I just summarize. I want to summarize here. At first, we are taking the stiffness matrix only for 3D truss, not 2D truss, because 3D truss we can use this formula. In the 2D truss, then it will be, we can use this formula, c square cs cx co square c square c, like this way, or other equation. These are the only for 3D truss. Okay, so that's why the formula will be changed. We have been shown how to derive the formula. If we derive this formula, then we will assemble. How will we assemble? These are the equation, and these are the only billet for the pin supported, the ruler, not ruler. So if we finding this value, if we go there here, so these are the member, as we've been shown here. The lot of correction, or lot of color is here. So this is the member which is called AD, DB, and CD. These are the main member. We've been shown AD, DB, and DC. This is the three member. So after we're calculating DB, DC, DA, we all the calculating LX, LY, LZ, and how we calculate L, square root of L square, LY square, LZ square, and this will be L. And how will calculate Cx? Cx is nothing but Lx divided by L. Cy, how will calculate the Cy? Cy is nothing but Ly divided by L. Cz, how will calculate Cz divided Lz divided by L. And finding and this, it is in the same way we can calculate the Cx square, Cy square, Cz square, and we also Cx Cy, Cy Cz, and Cx Cz. After putting this value, and we can the sum of the all values is here. Then will be, you have to take your brain will be you must be storming your brain, that why we are using this formula, as we are using this formula, but we are all the cancel out all the formula, but we just using this portion. Why we are using this portion? If you understand this, then you all will be easy to you. Okay, so as we have been shown, these are the equation, but we all the cancel out, just because this is the pin support, this pin support, this pin support, and this pin, this pin, this pin. Then we can see how we'll see, these are the, see, if we go here, 1 2 3 are the pin support, these are the pin support, that's why this will be cancel out. On the other hand, if we go to the this support, which is called 7 8 9, This is the 789 point C. This will be also pin support. That's why you cannot use this pin support is here. And other we can see the point B, which is called 456. This will be also 0. That's why you cannot use. Then why we are using this? So you have to take you have to must be take the note is that these are the node which there is no support. That's why we've been taking here. So there is no support. We've been seeing 10, 12, and 10, 11, and 12. So these are the 10, 11, and 12. These are the 10, 11, and 12. 10, 11, 12. So all other will be gone. So these are the main important thing. If you calculate in here 10, 12, and 11, these are the, you can say, K, and these are the displacement equal to force. This is the force is applied, load is on given here. Okay. So after applying the here and putting all this value and calculating, assemble this three equation and solve this equation with this calculator and putting this value, and it will be your answer. Thank you everyone. I hope that you can understand and you can enjoy. Thank you for your patience. If you have any question about this, then you can let me know. I will try to answer or solve your question. Thank you.